absolute value function. So as you continue in advanced functions, okay, so in math, now I'm pretty sure that you have covered absolute value even in elementary school at some point. Maybe you have forgotten it, but you certainly have utilized it throughout. Now, it's kind of neat to try to go over this absolute value and just understand, especially as you're just beginning, to talk about advanced functions. This is not a very complicated function, but it will allow us to kind of review numerous topics kind of from grade 11 functions as you go on. So what I'm going to do is, again, I love to treat these functions as kind of inputs and outputs. So, input is your x, it's your independent variable that's coming in. And then your output is your y. We have some function that's working on our input, f of x or f at x. And in this case, it's the absolute value. So I'm going to talk about, so the absolute value and inequalities, which is actually utilized quite a lot, primarily in providing restrictions of some kind. So maybe on your domain, maybe on your range, or just a regular restriction because you're defining something within your math. Okay, so I'll talk about that. I'll introduce this parent graph, so the absolute value of x, and then kind of how it looks back, just so that you can kind of recall it. And we'll dive into some of the transformations. Okay, so I'll do a few examples, okay, for this absolute value function, again, just to kind of bring you back from grade 11, because transformations you've done a lot, and I've done a lot of videos on those, so you can go back to that grade 11 content and take a look at that. And then we will graph them as well, because I think visually, students, I'm speaking for myself, I love seeing things in a visual way as much as possible. And since you are still not working with too crazy complicated things, and you can still visualize them, in this case it will be still in two dimensions because you have your x and then your y, might as well utilize the graphs to try to get some intuition into how they look like. All right, so for absolute values and the inequalities, what I'm referencing here is it's not so much that you have to graph them in some way, but instead that you actually understand how they're utilized in setting up restrictions. And so for instance, I may write something like this. I might set, okay, let's take a look at all the values of our input x, and let's make it so that it's greater than 1. Now, if this was just simply, x is greater than 1, then it's not a big issue, right? But because we have these absolute values around, then that changes things for us, because the absolute value means that if we have a negative value in there, it's just going to take the positive magnitude of it. So for instance, -2 still satisfies this inequality because the absolute value of -2 is just 2, right? So you may run into in kind of school, they might ask you to set up these kind of restrictions within these. Let's say this is 0, all right? And I'm going to put here 1, I'm going to put here -1, so this is going to be -2, okay, and 1, and so on. So now, which values actually satisfy this inequality? Well, we definitely know, and you may recall, so this is going to be, I guess this is 2, I'm sorry, this is 1. Okay, so we have 1 right here. Okay, so we're going to draw an open circle, and we know that this is going to be all the values kind of that are heading in this direction, right? So that's not a big deal. Okay, so that comes from there. The tricky part is of course that it also includes the negative values. Now, it's not going to include your -1, so we're going to put that in there as well, but it will include everything else, okay, that goes on to the left. So all of these values and the ones that are right here satisfy that inequality. And that's kind of useful to be able to know and to utilize, okay? Now, here is a very common thing that sometimes happens. We might take some kind of a restriction on these absolute values, and, someone might write something like this. And I know that this is actually true, because it happens in, for example, in scientific notation, where we need the mantissa, okay, to be between the magnitude of the mantissa to be between 1 and 10. Okay, maybe I'll put a link up above there if you want to refresh yourselves on scientific notation. But in any regards, the reason why I write this out, it's not really a domain or anything like that, but it's actually a restriction which is set on this variable m. Now this variable m, it just turns out to be a mantissa, okay, which is kind of the leading number when you represent scientific notation. So when you get into sciences, you eventually will run into this scientific notation, or you maybe have done so in the past. I hope if you watched my videos, you did. Okay, so now for this, if we wanted to now replicate and then see how this works, right? So if I draw, let me make this a little bit nicer. Okay, so if I draw, okay, so let me leave it like that. Okay, so if I draw this this line, so let's say if this is 0, this is going to be 1, this is going to be -1. Now, it's going to continue on, and I'm going to put here 10, and this continues on, okay, and it's going to get stuck here at -10. So within this restriction, what we have is that because it's the absolute value, then that means it's going to omit the 10 and 1, the magnitude of it, but it will include everything in between there. Okay, so notice here and here, it's going to include everything right there. And that is the restriction. So all the values that satisfy this inequality will fall in this, kind of pinkish highlighted what I have done. And that is the beauty of using the absolute value. So what I find is quite often we use the absolute value in various applications, and especially in restrictions. So this is just a review, and I hope that it kind of rings a bell to you. You might run into drawing these number lines and then kind of restricting them as you go along, or you might take these number lines and then you might have to be asked to transform them into, the actual restriction itself. So, if this is M right here, you might have to kind of get it back from that. All right, so that's the first thing, okay, that I wanted to cover in this video. So those absolute values and inequalities. Now, how does the parent graph actually look like? And this you may remember from grade 11, right? Let me just actually include, I'm going to put an extra page in here. Okay, and let's take a look at this page. So the parent function, which is the kind of the original starting point function, so parent function, of our absolute value, we typically will write, okay, as simply as this. So it's not very complicated, and it turns every value of x, so every input that we obtain. So it works for every input. There are no restrictions here at all. Okay, so the domain is basically all the real numbers. It's a continuous function. But, okay, it turns all of them to be positive. Now, of course, except 0, right? Because if we take absolute value of 0, it's still 0. So this absolute value, so the way that it looks like, if I was kind of drawing it on a number line, say if this is my y, if this is my x, okay, so if I was drawing it like this, then what we would find, you can also put yourself the numerical values as a table of values if you wanted to, and what you will find is that this function, so for all your negative values, so for all the values on this side, it will just make them positive, all right? And it's going to kind of have a nice straight line going up. And then for your positive values, all right, so as you go on, this also is a straight line. So it's almost like our absolute value, there's a reflection along the y of our line, okay, that we have. And it looks like it's made up of 2 lines, all right? So it's made up of 2 lines. It's made up of this line, which is y is equal to x, okay, in this form. So it has a slope of 1, right? It rises and it keeps going, so it's a straight line. So this is this right here, all right? And then it's made up of another straight line, except it has a negative slope, okay? And this negative slope, so the one that it's made up of, is kind of this one, all right? So it takes on all of those different values, and that would have been right here. Now, when you combine those two, okay, it's going to give you that absolute value. But of course, all right, so what it's assuming is, okay, so that in this case, so this line right here, this is kind of from 0 going onwards, because if we continued that line, it would just, still continue down, but we want to cap it. So it's made up of two lines. Here's your first one, and here is your second one. All right. And so the second one is on the negative side, and then the first one is on the positive side. And that's how your parent function looks like for this absolute value. So it's nothing really special in any way. That's all that it is. So now there is something interesting happening because, at 0, we have this little cusp, right? Like it just kind of gives you this cusp right there that we have, which is not necessarily happening with most of our functions. They're kind of smooth, okay, in some way, but this one is just kind of has an abrupt change and it goes over. So there's a problem there if you keep studying, and if you eventually get into calculus, we have a problem there with respect to taking what really is the slope at that particular point, right? Everywhere else it's a pretty nice function. So that's all I wanted to kind of review with you on that side. So that's your parent graph. Now, what about these transformations, right? So you may recall, your teachers might use different, I'm going to just kind of copy this and bring it down. All right, and I'll paste it. So your teachers might use, different constants here. So, I put A, here I put a D, okay, this is an H, this is a K. So these might change. It will depend on who's teaching, what book or textbook you're using, but it doesn't really matter. And for these transformations, what we're really interested in is, again, what happens if we're going to be multiplying our function by some A, right? So in this case, our parent function is right here. So what this would really look like, okay, if I wanted to draw this out, it would have been kind of like this. So, we're multiplying this parent function right here by A, okay? Our function, right, we're substituting this into our function. So if we're substituting this into our function, okay, then this is going to be dx minus h, all right, because we're substituted for this x, okay, that's right there. We've substituted all of this. So that's that, okay? And then finally what we're doing is it's almost like we're shifting our function. There's going to be plus some k, which is going to be a shift, either up or down, all right? So that's what's going to happen. Now in grade 11, I've studied, I've kind of did videos to exhaustion on these, and I gave numerous ones for pretty much all the functions you can imagine. But, in grade 12, as you study advanced functions, you might need a little bit of a review. So let's do that, all right? So I just wanted to kind of draw this out and use the absolute value also as kind of an introduction back to these transformations and then what happens. All right, so now that we kind of mapped these, okay, so from the general function to, let's say, our absolute value function, let's take a look what these transformations would do. So, and again, so this is kind of a review. So if we had an A, so this is some value of A, all right, so what would actually happen? Well, it turns out, okay, so if again, and notice the absolute value of A is between 0 and 1. So what's going to happen in this case, you're going to have a compression, okay, in the Y. So our parent document, which basically is just this V, it starts to compress down, all right? So it'll look like it's being compressed down. So that's the first thing. So there's a compression, okay, in the Y. Now, if on the other hand, we would have that A is actually, maybe I'll do this, so if A, the magnitude of A, or the absolute value of A, is greater than 1, then in this case what happens is it's like you have a stretch in the Y. Okay, so it's going to be stretching it out, okay, in the Y. And so what I mean by that is, let me pop up decimals again, so this is kind of as part of a review. Okay, so let's imagine, all right, so my function, okay, that I have is equal to, so this is going to be kind of absolute value, okay, of x. So notice that's my parent document, my parent function. And so here in front, okay, so if I have, Okay, I'm going to put, a little a in here. I'm going to put a slider for a, okay, just so that we can see what actually happens. All right, so I said that, if my a, so within here, so notice, if it's going to be between 0 and 1, all right, so notice that there is a compression, right? So it's almost like we're compressing this thing down, and if we're going to have, and this doesn't matter if it's positive or negative. Now, the only thing that does happen, if A is negative, you start having a reflection, right? And you start having a reflection in the X. And this is exactly what we see. Now, on the opposite sides, if it's going to be greater than 1, okay, so notice what happens is that it's like a stretch, it's like a pull out in the Y direction. So that's what A actually does, right, to all of these things. Now, let's kind of continue on and let's see what all the other ones do. Now, what about the D? Do you remember what the D used to do? Well, the D kind of works in the X, okay? So it either compresses or stretches in the X. So that's what you would see there. So let's take a look. So let's say, if our D, okay, and let's make it, okay, between 0 and 1. And I'm going to introduce, okay, and then the other item is that we're going to have our D is going to be greater than 1. And let's take a look and see. So we should see a compression and a stretch, except now in the X. So it's either going to be kind of pushing in this way, so, compressing it in this way, or stretching it out kind of in this way in the X direction, right? So it's almost like it's the opposite of what happens in the Y. So let's take a look. So if I go back in here, I'm going to now add another. Okay, I'm going to say let's pull this as D. Okay, so it's going to be dx. Okay, I'm going to do that. We'll bring this one to 1. Okay, and now let's take a look and see what happens with the D. So if D is greater than 1, so notice that it's like stretching it in the Y, but compressing it in the X, right? Because it's compressing it in this direction. So stretch Y, compress in the X. So when D is actually greater than 1, that's what's going to happen. Okay? Now, if D is going to be between 0 and 1, so if I take this, notice that it's like a stretch in the X. Stretching in the X means that you're pulling it apart, or like you're compressing it in the Y. Okay? So that's what you would see within that D. Okay? So that's what we would have in there. Now, if the D is negative, it actually doesn't matter because of the fact that, we would typically have a reflection in the Y, but because this is symmetrical, right? Our parent function is very symmetrical and we have the absolute value. So the negative is going to get canceled off. So it doesn't actually matter. If I go in this direction, okay, and it's negative, it still does exactly the same thing as if it was in the positive, because the negative by the absolute value will be canceled out and you only take in positive values. All right, so that's what you would see within there. Okay, so that's kind of a review within that. So between 0 and 1, it kind of gets stretched out, okay, in this direction, and then when it's greater than 1, it gets compressed in this direction or stretched out in the Y, right? So now, we also have, so we have this, h in here, so x minus h and then plus the k. These ones from your transformations, you may remember, this is kind of the simplest ones because these just simply tell you. So the h, okay, refers to a shift, and this is going to be a shift in the x direction. And then the k refers to a shift, but in the y direction. So it's going to either make it go up or down. The only thing that's kind of annoying is that this is going to be negative, right? While here it's positive. So you have to be careful about that, all right? So let's take a look and you'll see that happening. So if I introduce this into here, all right, now I have to put brackets around here. So this is going to be minus h, okay, and then outside plus k. So I'm going to put all of these in there. And let's return these back kind of to 1, just so that you can see what happens. Actually, so that's 1, and a is 1, okay, and now I'm going to put this one at 0 first. And now notice the h just shifts over, so it will shift it right or left. So notice, if it's positive, it's going to be shifting it to the right. If it's negative, it's going to be shifting it to the left. All right, so that's your H, that's the transformation there. Your K is going to be either up or down. So notice if I grab it, if it's positive, it goes up. If it's negative, it will go down. And that's exactly what you have in these. So it's kind of neat, right, to be able to see these things happening. And, you know, for examples, so, you know, I have 2 examples within here. So now we can kind of think back of like, oh, okay, you know, what would happen if we graph this out? You know, we can go back and think, well, this is your A, so it's 2. So, you know, what did we say? Well, if it's greater than 1, so this is your A talking, then what's going to happen is you're going to have almost like a, you know, within here, it's almost like you have a stretch in the Y, right? So that's what we would expect to happen. Now, in here, this is a little tricky because you have to put it in the right form. So, you know, always put it in the form where your, you know, your X have to factor out the -2. So this is going to be X. I guess this is minus, and this is a half, or 0.5, to, you know, to keep it the same. So this is your D, and this is, because this is negative here, this is going to be your H. And then this is going to be your K. All right? So the -2 means that we have, well, negative typically would mean that we would have a reflection in the Y, but because we have an absolute value, you know, it just mirrors exactly the same thing what we had. But the 2 does mean that, you know, we'll have either a compression or a stretch, okay? So that's what we should expect to see. And then the 0.5 just means that it's going to get shifted to the right, and then the -1 for K, okay, just means that it's going to get shifted down. So let's take a look, you know, let's see what happens there. I'm going to bring this out, actually do it side by side, and this is what we're going to do. So my H, all right, so H was 0.5, okay, and you'll see that it gets shifted down. My K is 0.1, so, sorry, the K shifts it down, the H shifts it to the left. Your D was supposed to be -2, all right, so it's almost like we have a compression in a little bit, and then my A was supposed to be 2, so that's going to be another stretch, all right, in the Y. And that's exactly what we would expect. Now, for the second one, so notice we have -3 as my A. So that -3, so it's going to, you know, stretch it all out. That's what we would have there. But it will also reflect it in the X. All right, so that's what we would have. Now, this one, again, we have to watch out a little bit. So we have 1.5. Let me factor that out so it looks in the form that we need. So negative, I guess this is going to be, what, 3? And so that's going to be that. So this is -3 plus 0.5. Maybe what I'll do is I'll put an extra one in here. Okay, let's, you know, create a new one. So -3, you know, then we have the absolute value. This is 1.5. So we have a stretch and a compression. Okay, and this is X minus 3. And that's the absolute value, you know, plus 0.5. All right, so that's what we have in there. So if I kind of zoom in here, all right, so notice the -3 shifted it, so 3 units to the right, so that's my H. My K was 0.5, so it went up by a half, all right, and then we had the 3 and 1.5, so those are our kind of compressions and stretches, right? The negative in front means that it reflected it back. So this is, you know, a little bit of a review for you with respect to transformations, which I'm sure you're going to see a lot in your advanced functions course, but you've also seen it in grade 11 as well. All right, and that pretty much covers it. So these are your transformations, and then, you know, I did the graphing along with it. So I hope that's a good introduction for you, and it kind of gives you a deja vu of the absolute function. All right, okay, thanks for watching. We'll see you in a future video. Bye, everybody.